Hi guys, welcome back to my channel. Myself Bharatji. Today I am here to give my presentation on subject mathematics and today's our topic is Latin square design. In this video we are going to know about introduction of Latin square design and the key features of the design, construction of the design, advantages, limitations and main applications of the Latin square design, and at the end conclusion of the Latin square design. Let us move into the video. For the beginning, introduction of Latin square design. A Latin square is an arrangement of symbols or numbers in a square grid. Latin square means arrangement of symbols or numbers in a square grid sequentially is known as a Latin square design. It enhances symbols or numbers appears only once in each row and column of the grid. The symbols or numbers appears only once in a row or column which will be not repeated in the same grid. Latin square are commonly used in combinational mathematics and statistical experimental design. These Latin square are used in so many fields in mathematics. The main fields are combinational mathematics and statistical experimentals, which will give more efficient use. Next one, key features. Latin square design allows for the systematic control of multiple factors. This square design allows us to control the multiple factors at a single time. It enhances that the each factorial level appears exactly once in each row and column. It enhances us that the each row and column should be represented only once in the square grid. By minimizing confidentiating effects, Latin square design enhances the precision and accuracy of the experimental results. By minimizing the confidential effects of the square grid, the Latin square design enhances the precision and accuracy experimental results. Main one, construction of the square. The first step in constructing a Latin square design is to determine the number of levels for each factor. The first step in square design is to determine the number of levels for each factor which we have to present in the square grid. The number of levels should be equal to the number of rows and columns in the Latin square. The number of levels should be equal to number of rows and columns which will be equal to the number of levels in the square grid. Each factorial level is assigned to a row and column, ensuring that no level is repeated with a row and column. Each factorial level will be allocated to each row and column. There will be no repetition of representing different levels and rows for the same numbers or symbols. Advantages of the square. Latin square design allows for an efficient use of resources as fewer experimental runs and needed. It provides a balanced representation of each factorial level across different treatments. It provides a factorial level across different treatments which helps us to balance the representation of the experiments. Latin square design is flexible and can accommodate a wide range of experimental designs and objectives. The Latin square design which we have designed is very flexible and can accommodate wide range of experimental results and objectives at a single time. Next, limitations of the Latin square. Latin square design is not suitable for studying interactions between factors. This Latin square design which is not suitable for studying interaction between the factors. It assumes that the effects of the factors are constant across the rows and columns. This Latin square which we have created will assume that the effect of the factors are constant at the each row and column and which will not give any proper output for the resource. The number of levels for each factor should not exceed the number of rows and columns in the Latin square. The number of levels should be equal to number of rows and columns. It should not exceed more than the rows and columns which we have represented. Now, applications of the Latin square. Latin square design is widely used in agricultural research to study the effect of different treatments on crop yield. The main use of Latin square design is it is used in the agricultural field, which helps us to study the different methods which we use on crop yields. It also applied in clinical trials to assess the efficiency of different treatment on patient outcomes. This Latin square design is also used in the clinical trials to test a medicine on a patient, which gives a proper treatment or not. The Latin square design has been used in manufacture to optimize process parameters. The square design which will use it in the manufacturing industries, which optimizes the process of parameters. Now conclusion, Latin square design is a powerful experimental design technique for controlling confidential variables. It is a Latin square is a powerful experimental design technique for controlling the confidential variables. It provides a balanced presentation of factorial levels and allows for an efficient use of resources. The Latin square design, which provides a balanced representation of factor levels and allows an efficient use of resources. By minimizing confidential effects, Latin square design enhances the precision and accuracy of experimental results. This Latin square design, by minimizing confidential effects, Latin square design enhances the precision and accuracy of experimental results. Thank you for watching my video. Please like, share and subscribe.